This is Dr. Holt. I want to go over 3 of the web assigning problems. Hopefully by doing this it'll help you get some of the homework done. This one is, I think this is 9-1. This is a 80.8 kilogram airplane pulls out of a dive by following a constant speed of 193 kilometers per hour. The arc is, okay, at the bottom of the circle. So all you want to do in a problem like this is go ahead and just draw yourself a simple circle. And you have a plane down here at the bottom sitting here. Now if you look at the plane and draw a free body diagram of the plane at the bottom, what you will have will be this. Oops, get a vector here. You will have mass of the airplane pilot coming down here, because we're only going to be worried about what the force that the pilot is going to feel. So we take 80.8 times 9.8, and that's going to give me a value of 791.84 newtons coming down. You're going to have the force that the seat is pushing back on him of going up like this. So this is a force that pushing on him. We can call that the seat pushing on the pilot. And then off to the side, just put your mass times acceleration going back up. And this would be 80.8 times the centripetal acceleration. Now to find the centripetal acceleration, we know the centripetal acceleration is equal to the tangential velocity squared divided by the radius. Now in this one, you know what the velocity is. You're doing 193 kilometers per hour. So I'm going to take 193 kilometers per hour. I'm going to convert that back to meters per second. So here I'm going to have 1,000 meters over 1 kilometer. I got hours in my denominator. I'll put 1 hour up here. I'll put 3,600 seconds down here. And you notice that hours cancel out, kilometers cancel out, and kilometers cancel out. We'll run that calculation. 193 times 1,000 divided by 3,600, and we have 53.6. So my tangential velocity is equal to 53.61 meters per second. Alright, and then our radius, let's see what our radius was. Our radius was 276. Alright, so all you have to do in this one, we'll just do summation of forces in the y direction. Set that equal to mass times centripetal acceleration. We'll get minus 791.84 plus the force the seat is pushing on the pilot must equal to velocity squared 53.61 squared over 276. That's my centripetal acceleration, and then times the mass of the pilot, and again the mass of the pilot was 80.8, and we'll solve for that. So I take 53.61, I'm going to square that. I'm going to divide it by the radius, which we said was 276. We'll multiply it by the mass of the pilot. And this would give you a value of 1633.26 newtons. Okay, so that's going to be the force the seat is pushing on to the pilot, which is going to be this answer right here. The next, moving back up, is just what's the net force acting on him at the bottom of the circle. Well, we know that net force must be equal to mass times acceleration. So to find that value here, it would have been what we had right here. So that's all it is. So you can take this value here and subtract the 791 we had before, and that'll give you the 41.42 newtons. So this would be the answer for B, and this would be the answer for C. And just go back up and we'll just check those right there, and which is correct. Alright, looking back up, the other ones obviously we can figure those out. At the bottom of the circle, what's the direction and magnitude of his acceleration? Well, acceleration would just be the velocity squared divided by r, and that'd give you the 10.4, and obviously the direction is going to be up because of velocity. As you're coming down here, the velocity as you're moving along the circle, the velocity is, the angle is changing, the magnitude is not changing, so the acceleration will always point back toward the center. Alright, let's look at one more problem here. Let me change the colors here. On this one, you're swinging your younger sister in a horizontal circle of 0.79 meters. Her mass is 21 kilograms. You arrange it so she makes one revolution every 1.5 seconds. Well, you know that the circumference of a circle is going to be 2 pi times the radius. So all we need to do here is to take the distance traveled and divide it by the time interval. We'll call that delta t, and that'll give us our velocity tangential as we travel around the circle. So we do 2 pi times 0.79. We will divide that by 1.5 seconds. Run that real quick. 2 times second pi times 0.79 divided by 1.5, and that's going to give us a velocity, a tangential velocity of 3.309 meters per second. Now, one thing you need to realize is when you're swinging someone in a horizontal circle, it's impossible for, like if you're attached to a rope or attached to their arm, it's impossible for that person to be horizontal, especially when they have mass. So if you look at your free body diagram, what you would end up getting would be something more like this. You'd have the mass times 9.8 going down, like that. You would also have this force here, which is the force that you're swinging your younger sister in, and then off to the side you'd have mass times acceleration. So here you would have the mass, which is going to be the 21 times the centripetal acceleration. Here you'd have 21 times 9.8. Here would be, you call it the force that you have on your sister. Alright, so obviously we know there has to be some angle present. It's impossible for that not to be when there is mass with the object when it's going around into a circle, so we can call this into theta. So let's find out what our horizontal component is going to be. So if we sum our forces in the x direction and set that equal to mass times centripetal acceleration in the x direction, then we will get, here we'll do summation of forces. I'm going to let anything goes this way positive this time. That's going to be the mass of the person. Actually, I'll do the force, sorry. We'll just call it force of x. Force of x is going to equal to the mass, which is going to be the 21 times the velocity squared, which we said was 3.30. Let's make that O a little bit better. 3.309. We're going to square that. We'll divide that by the radius, and the radius of that is what? 0.79. So we'll run that number real quick. 21 times that's going to give us a force in the x direction of 291.09 newtons. So we're sitting at right now is we have a force here. The component, I'll do that with a vector. The horizontal component of this is going to be the 291.09. Coming down would be the 21 times 9.8. And that's going to give us 205.8 newtons. Alright, now the only way this is going to be to take place is we got to have this vector going up here. and its components is going to be this one here going horizontal and the 205.8 going back this way. Because we know that object is not going to accelerate vertically. So we can find out what this force is by using Pythagorean theorem, and the force that you or on your sister is going to equal to the 205.8 squared plus the 291.08 squared. We take the square root of that, and that's going to give us a value of 356.5 newtons here. Go back and just double check that, and this is where this value here is coming from here. Now if you want to find the direction, all you have to do is take the inverse tangent of 205.08 divided by the 291.09, and that will give you the value here. Obviously this is just goes back to equal and opposite. What's the magnitude and direction? Obviously it's going to be the sister's going to be pulling back on you the opposite, so the angles would be just, it would be below this time the horizontal, but the magnitude would be the same. Alright, there's two problems that are provided to help you a little bit with the homework. The third problem I want to work is another WebAssign problem here. This one, you have a curve of radius 165 meters is banked at an angle of 12 degrees. A 756 kilogram car negotiates the curve at 94 kilometers per hour without skidding. Neglect the effects of air drag and rolling friction. You want to determine the normal force, the frictional force, and the minimum coefficient of friction. Alright, I know I keep coming back to this, but all these problems are all based upon good free body diagrams. If you draw that, you're not going to have any trouble whatsoever getting these problems right. If you don't draw them, you're going to struggle and you're not going to get the right answer. So watch this. I'm going to draw myself the car first, just make a quick little sketch. I'm going to come over here, draw the car in the orientation it is. I'm going to make this angle here to be my 12 degrees. It'll be at 12 degrees here. Off here, I'm going to do my mass times acceleration. Let me do that with the vector. You know the road's going to be pushing back up here. Now the thing about friction, you really don't know. Friction could go this way, it could go this way, or it could be non-existent if you're going the right velocity. We will play around with it, assuming worst case it's going to go down. So our friction is going to do that. So now let's go ahead and draw our free body diagram. Oh, I'm sorry, I need to left. Excuse me, I need to do this too. Sorry, this is my mass times gravity. So now, when I draw my free body diagram, it's going to look just like this. I'll have mg coming down, which in this case, this is going to be the mass of the car, 756. 756. I'll erase that here. Times 9.8 coming down. That's going to give me a value of 7408.8 newtons. Actually, I'm going to grab that and move it. I'm going to move all this down to here because I need to show where the everything's going to be. All right, I will have the force the road's going to push back on the car. That's the normal force right there. We will call this value Fn. Here I will have friction going back down like this. This is a right angle here, and then off to the side here I'll have the mass of the car, 756 times my centripetal acceleration. This will give me friction. Alright, now I'm going to go ahead and show where the angles are going to be. Come over here, come over here. This angle right here is going to be 12 degrees. This angle here is going to be 12 degrees. Alright, to solve the problem, we need to first get the velocity back into meters per second. We know, we'll just take this, 94 kilometers per hour is equivalent to, I think, approximately 26.11, I'll just say 1 meters per second. You can run that number if you want to. So now I'm going to come down here. I'm going to do the summation of forces in the x direction. I'm going to set it equal to mass times acceleration in the x direction. In my case, I'm going to let anything that goes left to be positive this time. You can make it negative. It makes no difference whatsoever. When I do that, my forces are going to be the normal force, F normal, times the sine of 12, plus my frictional force times the cosine of 12. And that must equal to the mass of the car, which is 756, times my velocity, 26.11 squared, divided by the radius, which is 165 meters. I believe that was given in the problem up here, 165. First equation. Okay, second equation, summation of forces in the y is going to equal to mass times acceleration in the y direction. Now we know, looking at the picture, this car is not going to accelerate down or accelerate up in the sky. So we know immediately this is going to go to 0. So now we just write our equations down as minus 7408.8 plus F normal times the cosine of 12 minus F friction times the sine of 12. Okay, to solve this, again, you got two equations, you have two unknowns. I set up as a matrices. I did Fn, I did F friction, and I did my values here. Like this. Okay, take the first one, I put the sine of 12, I put the cosine of 12, I ran that value here, and I believe I got 3123.84. I come down to here, I put the cosine of 12. Be really careful with the signs, that's going to be minus sine 12. I'm going to move this back to the other side, it's negative here, so that makes it 7408.8. I run that through my calculator very quickly, and what I'm going to get is my F normal. What's the road pushing back on the car is going to equal to 7,896.4 newtons. My friction is going to equal to 1515.2 newtons. Now if you want to get coefficient of friction, you know that mu s is going to equal to normal. Sorry, do that again. Let me rewrite that too. I'm going to solve for mu s, but let's say this. We know that normal times mu s is equal to friction. So we know that mu s is equal to friction divided by my normal. So I'll just do that right here. I take 1515.2, I'll divide it by my 7896.4 value. Gives me a frictional coefficient of about 0.192. Let's go up and check our values. Again, this is my value for normal. This is my value for friction. And this is value for my coefficient. And you can see they're all correct. Again, if you do not draw a correct free body diagram like I did here, you're not going to get this problem right. You're just guessing in the air as far as the way to do it. If you draw a free body diagram and off to the side show your mass times acceleration, then you can see what's taking place, and then you write your two equations, and then the problem is really easy to solve. Alright, best of luck. I hope this video helps you. I've demonstrated how to solve 3 problems.